All right, completing this T-chart, we use the unit circle, and for cos that this is 0 radians, that ordered pair is 1, 0. At pi, it's 0, 1. And if you remember, cosine is the first order pair, sine is the second order pair. Okay, so on our graph, you have this labeled every fourth one, pi over 2, pi, 3 pi over 2, 2 pi, and then I just translate it to the negative. And then we're going to go up 1, 2, 3, 4, let's go 5, and make the fifth one a 1, and go down, make that a negative 1. And so we're going to graph the ordered pairs that we just made. So the first order pair we had was 0, 1. So we're going to go over 0, up 1. Next one is pi over 2, 0. Pi goes to negative 1. 3 pi over 2, 0. And 2 pi is 1. Ordered pairs, 0, 1. This is our theta, so to speak. This is our f of theta. And so these are our 1, 2, 3, 4, our 5 ordered pairs. These are what I call the 5 important points of the cosine and sine graph. We have 5 important points. Now, how do I get the others? Because you can see up here on the board I have cosine, I have sine. You can see the cosine starts right up here. Well, what is between 0 and pi over 2?
4.
Pi over 4. What is the cosine of pi over 4? Square root of 2 over 2. Someone take your calculator and take square root of 2 and then divide it by 2. Give me a decimal equivalent approximate.
You get 1.
What?
You get 1.
No, you don't.
No.
Square root, what'd you get?
0.7.
0.7. You did square, yeah.
Yeah, I did.
Yeah, 0.7. So square root of 2 over 2 halfway, well, that's about right here, somewhere in here. It doesn't necessarily need it there. But what happens is this graph starts right here and we follow and then it goes down from here. When you start graphing these graphs for me, you're going to, when I'm going to ask for one period, and we're going to get that in a minute, this is the part I'm going to look for. So when we start graphing, you're going to know that the cosine looks like a U. All right? Now what happens over here? Well, if I go negative pi over 2, if I go down to negative pi over 2, what's the cosine there? So what's the cosine? 0. So at negative pi over 2, it's 0. At negative pi, I rotate clockwise, it's at negative 1. Negative 3 pi over 2 is the same as pi over 2. And negative 2 pi is the same as 0, which is the same as 2 pi. So what you can see I just highlighted this in yellow, what do you see happening here? You see how it keeps repeating. You have this u, and then you have the u. This is what your cosine function will look like. It's just going to be, your u is going to just keep repeating. Questions there? Okay, let's do the sine. Y equals sine of theta. Fill out your scales just like we did the one up above it. All right, let's graph our ordered pairs. So for sine, the first ordered pair is what? 0, 0. Then it's pi over 2 and 1. It's pi 0, 3 pi over 2, negative 1, 2 pi 0. So it was 0, 0. Then from the table, it was negative pi over 2, 1. Then pi 0, 3 pi over 2, negative 1, and 2 pi. Negative pi over 2 is going to be the same as which one? If I rotate clockwise, 3 pi over 2, so it's going to be down here at negative 1. Negative pi is the same as pi. 3 pi over 2 is going to be the same as pi over 2. And negative 2 pi. And what do you see? You see the same graph repeating. These are the parent graphs. And as you know, like when we had y equals x squared, we started doing things with that, like y equals x squared plus 2, y equals x minus 2, quantity squared plus 3. We put a number in front of that. We started doing different things with that, and the same thing's going to happen here. Everyone done with these graphs? These are our important points here. 1, 2, 3, 4, 5. These are our x-intercepts, our maximum, and our min. Up here, x-intercepts, maximum, and a min. And if you remember, back when we were talking about sine and cosine, I told you that the value of the sine and the value of cosine are always between 1 and negative 1. And as you can see, these values, the range, highest is 1, lowest is negative 1. Okay, what do these look like from physics? Look like those wave signs. I was in the copy, what? I was in the copy room and Mrs. Lizzie was drawing, I had a copy there. I go, oh, looks like you're talking about the trig function. She goes, well, this is ICP. We're just talking about sine and waves, but she said we're not talking about them in terms of trig identities. So what do we know about them? Well, let's look here. A sine wave or a sinusoid is a waveform whose graph is identical to the generalized function y equals d plus a sine of bx minus a. You can see there's 1, 2, 3, there's 4 parts of this. Okay? The absolute value of a, that's the amplitude. What do we mean by amplitude? How tall it goes. Okay? 2 pi over b is the period. What do I mean by period? It's where my cosine, it's where that U shape repeats itself. For the sine, I like to say, well, this is kind of an S shape, right? So this is kind of an S shape here. So for that, it's where that sine, that's where that repeats. That's the period. Okay? C over B is what's called the phase shift, which is a horizontal shift. That means I'm shifting it this way to this way. And then D is the vertical shift where I shift it up or down. And you can think of D as if I had y equals x squared plus 2. Where does the x squared's vertex go? It goes from 0, 0 to up to 2. It just moves it up 2. All right. The wave pattern occurs often in nature, including ocean waves, sound waves, and light waves. The cosine wave is also said to be a sinusoidal since it has the same shape but is shifted slightly beyond the sine wave. Let's look at these. For this sine wave, can you see that U-shaped right here?
Yes.
Here's the U-shaped. It starts at 3 pi over 2 and it ends at pi over 2. So this one is just shifted to the left to 3 pi over 2. Okay? So they're the same graph. If I could cut this out, if I drew them perfect, I could lay them right on top of each other. Okay? And you can see beyond the wave, they did minus 2 pi. All right. Here's the same information for the cosine. It's d plus. Absolute value of a is amplitude. We're talking about how tall it is. That's a positive. If it was a negative, what would happen to the graph? It would flip it upside down. 2 pi over b is the period. C pi over b is the phase shift. And d is the vertical shift. All right, so let's look at what's the range. I'm sorry, domain. What's the domain of sine? All real numbers. We're going to write it from negative infinity to infinity. What's the domain of the cosine? All real numbers. What's the range? Between, do I include -1 and +1? Yeah, so we'll use brackets. Is that true for both of them? Well, since they're the same graph shifted, sure is. What's the amplitude? How tall are these graphs? They're just 1 unit high, so 1. For the sine function, what are your x-intercepts between 0 and 2 pi? 0, pi, and 2 pi. What's your x-intercept for the cosine?
Pi over 2 and 3 pi over 2.
Guys, we're just looking at the graphs and filling this in. What's your y-intercept for the sine? 0. What's your y-intercept for the cosine? 1. The sine is an odd function because it has symmetry with the origin. And the cosine is an even function because it has symmetry with what? Look at the graph. Where does it have symmetry with respect to?
The y-axis.
The y-axis. Questions there? Okay, let's look at and do some graphing. Sketch the graph of y equals 2 sine of x, y equals 1/2 sine of x, and y equals h of x, and h of x equals negative sine of x. Guys, I don't provide you with xy coordinate grids on here, all right? Because I just don't. When we start changing, we start changing the periods and things, and so I like to, when I make them, I like to be able to, we got 5 important points here. 1, 2, 3, 4, 5. Okay? Those 5 important points, since what's changing here? What's the only thing changing on here? What's the A value do? Amplitude. It's the only thing that's changing. The period stays the same. Amplitude is the only thing that's changing. It's height. So I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. I only expect one period. That's all I ask you to do. Now I might, on the test, if I give it to you, I might want you to fill it in. But we'll talk about that. You can repeat it, yes.
Can we use these?
No, do not use these. Because with these, the graphs that I gave you are for the 6 trig functions. There should be 6 of them there. There's 6 of them. All right. So where does the sine graph start?
0.
And where does it end? Starts at 0, 0. It ends at 2 pi. So its x-intercepts are at 0, pi, and 2 pi. Because of the 2 in front of it, instead of going up to 1, where am I going to go up to? 2. And then at 3 pi, I'm going to go down to negative 2. And there's our shape. The half, instead of going up to 2, it's going to go up how high? It's going to go up just to a half. So at pi over 2, it's still going to, the x-intercepts aren't going to change. The only thing that's going to change is our amplitude. then the negative just causes the original function to what? Flip. So instead of going up to 1, we're going to go down to -1. And if you'd like, I will dot in the dot is my original parent y equals sine of x. And as you can see, the numbers in front, all it did was either stretch it out or compress it or flip it. Questions there? Everyone done? Okay, let's look at what happens when I have a period change. We're going to start with y equals cosine of x over 2. And I'm going to start with what's the amplitude? How tall is this function? One. It's just the number in front. It's just this number here. There's a 1 there. So our amplitude is 1. To find the period, because the original function has a period of 2 pi, we take 2 pi and divide it by b. We've got to be able to find b. Well, b is the number that's in front of the variable x. This is x over 2. What is the coefficient? It's 1/2. Dividing by 2, this is the same as taking 1/2 times x. So we're going to take 2 pi divided by 1/2, and what do we get? 4 pi. Because dividing by 1/2 is the same as multiplying by its reciprocal. So we have a period of 4 pi. Okay, we have an amplitude of 1, so it's going to be 1 and -1. When you graph these, all of your graphs are going to look exactly alike, except we're going to, instead of taking this to 2 pi, I'm going to change my scale on my graphs. So for cosine, it starts up here, it ends up here. Well, that's the period of 2 pi. This one has a period of 4 pi. So instead of ending at 2 pi, where's it going to end? It's going to end at 4 pi. What's halfway between 0 and 4 pi? 2 pi. Halfway between 0 and 2 pi? Pi. So it's 1 pi, 2 pi, 3 pi, 4 pi. My cosine starts at its amplitude, ends at its amplitude. What happens halfway between them? It's down to its minimum, which is -1. And then between the maximum minimum, we have our x-intercepts. Those are our 5 important points. Questions there? So I've done one where we've changed the amplitude only. This one, I changed the period only. Now we're going to start changing more than that. We're going to start doing some phase shifting here. Easy stuff. Okay, so what's the amplitude here? 2. Okay, period. That's found by taking 2 pi, dividing it by b. What's your b here?
Negative x over 2.
What number's in front of x?
1.
1. So that's just 2 pi over 1. So the period does not change. For phase shift, for the beginning and the end, the easiest way to do this is whatever you're taking the cosine of. Cosine minus pi over 3, or x minus, sorry. Where does your original function begin? 0. Original function starts at 0. Where does it end? At 2 pi. All right, so our beginning of our cycle is going to start at x equals what? Pi over 3. And it's going to end at, here's where you're going to have to become really good at fractions. So I've got 2 pi, take away 1/3, I'm sorry, how about add? Add 1/3 pi. Well, this is 6 pi over
5 pi over
3. 6 divided by 3 is 2. Plus 1/3 pi, 7 pi over 3. I wrote 2 with a denominator of 3. 6 pi divided by 3 is still 2. I rewrote it so I had common denominator so I can add. And so where are we going to start? Pi over 3. 1, 2, 3, 4, 5. Where are we going to end? We're going to end at 7 pi over 3. We need to figure out what's halfway between pi over 3 and 7 pi over 3. How do I do that? It is 4 pi over 3. How'd you get that?
In the middle of 1 and 7.
Between 1 and 7. Or 7 plus 1 divided by 2 gives us 4. Now what's between 1/3 and 4/3? We've got 1/3, 2/3, 3/3, 4/3. What's halfway between them? Whatever's right there. 5/6. This is 4/6. This is 6/6. So it's 5 pi over 6. 2, 4, 6. 2, 6, 4, 6. So now I need to find what's halfway between 4 pi over 3 and 7 pi over 3. So this is 8 sixths, this is 14 sixths. How about 11 sixths? Yep. There's where you guys are going to have some of the fun. That's where you're going to struggle the most. And so now we're looking at cosine. We're trying to graph cosine. Where does cosine start? Starts at the amplitude. So at pi over 3, it's going to start up here at 2. At 7 pi over 3, it's going to end at 2. Right smack dab in the middle, it's going to end at negative 2. Halfway between are those zeros. It's the same graph as cosine. It's just shifted a third units to the right. Questions there? Okay, let's look at one more. And mine didn't. So we're sketching y equals 2 cosine of x minus 3. What's its amplitude? 2. What's its period? 2 pi. There's nothing in front of the x, so it's going to be 2 pi. Where is it going to begin?
3.
Well, it's going to be whatever this is, set equal to 0 and 2 pi. Am I shifting it horizontally at all? No. So it's going to start at 0. It's going to end at 2 pi. But it's going to have a vertical shift that is down 3. All right, so let's get our graph set up. Oops. So it's down 3. So I'm going to take the origin, or the x grid, and I'm going to shift it down 3. So I'm going to draw a dotted line here.
Is that first point pi over 2?
Is what?
This should be pi over 2.
Yes, thank you. When I do vertical shifts, I draw this dotted line here, and I pretend this is my origin. So where does cosine start? Have I done all cosines? So where does cosine start? It starts up at its amplitude, right? And how tall is this? 2. So from here, I'm going to go up 2. At 2 pi, I'm going to end it up 2. At pi over 2, I have to go down 2. And then halfway between is where it intersects that vertical shift